Roberta Hom at the University of Victoria, and today I'm going to show you how to collect a dissolved gas sample. So when you receive a box from us, it'll look something like this. It's fine to FedEx or send these as checked baggage on an airplane, etc. You open it up, you'll see there's a piece of foam on the top to protect the bottles during shipment. It just pulls right out. You can leave this out when you're actually doing your sampling and things, but make sure you put it back in before you ship it to us. And the bottles just fit in like this. If they're angled, then the necks won't interfere with each other. This is what our bottles look like. We have a couple of different kinds. This one you can see has a thick wall. Generally we only use that locally because they're kind of heavy. Some of our bottles, if we're going to use them for oxygen or nitrogen analysis, we like to have mercury inside to kill the biological activity once the sample is drawn. Yeah, you can see mercury actually dried in here. And we usually also mark the bottle mercury so that you know, yes, it's got something dangerous inside it. The way these work, I'm gonna open this one up. It's got a plunger with several O-rings here. You can see there's threads on the top of this glass, and then there's threads inside the white plastic cap here. So this just fits down inside, and you turn it to make a seal of these bottom O-rings between the plunger and the inside of the glass here. Next I want to show you our rack. It's handy to have some way to hold the flask while you're sampling, because otherwise you just won't have enough hands to do it. It doesn't have to look just like this, but this is the one we use. The flask is held in this clip here, and then this tubing has another little clip at the top, and at the back we have a rack to hold a compressed gas cylinder. So we need compressed CO2 to take these samples. We use these little 5-pound cylinders, 5 pounds of CO2 in here. These are available at many fire extinguisher companies. The regulator, the only important thing here to note is that for carbon dioxide there needs to be a washer. You can see this one's been used a couple times and it's just stuck in there, but you want to not see bare metal at the bottom. So, I just hand tighten that and then use a wrench. Get it good and tight. Use the style of holder. This elastic band just stretches around. Hold the cylinder like this. Any way you want to hold the cylinder is fine, but it's important that it be upright. Carbon dioxide, when it's compressed, is a liquid, so if you have the cylinder on its side, you'd have liquid CO2 come out through the regulator instead of gas. On some ships we also use a full-size CO2 cylinder that can just be secured on the side of the ship, and then you can run a very long line to where you're actually doing the sampling. We use 2 thin nylon tubes, one to run the CO2 through and one to run the water sample through. On the CO2 regulator here, you can see there's a little quick on-off valve that's kind of handy not to waste CO2, but it's not absolutely necessary. And this just fits up in here. It's not really necessary to form a gas-tight connection in here because the carbon dioxide will be under pressure, so air can't actually go in. You just want something that's not going to pop off. I'm going to use a flask that's already had a sample in it, just because it takes a long time to clean these flasks, and it'll work well for our demonstration purposes, but when you receive a flask, of course, it won't have water droplets in, it will be perfectly clean. So what it will have, you'll have a very high vacuum inside the flask and also in this little space between the O-rings here. We'll have done that in our lab before we ship it to you. For demonstration purposes, before I took the plunger out, you do not want to do that because you'll release the vacuum. And we'll have also put carbon dioxide into the neck here and place this cap on the end. This is to keep air from leaking across the O-rings and into the flap. When you're ready to sample, take your cap off, put it somewhere where you won't lose it, and you want to attach this tubing. This is 5/16 inch ID, just regular Tygon tubing. This is 3/8 OD, so this doesn't quite fit, it's a tight fit. If you have a hard time getting it on there, a little chewing, a little spit goes a long way. Just want to have it on like that. The purpose of this is to essentially make this little neck much longer. Flask end sits in like this, and you've got a long neck. We're going to take a sample now. The first thing we want to do is start the flow of carbon dioxide. So turn on the cylinder here. This is on. And you want to feel, no, I don't feel anything. So just adjust the pressure of the regulator slightly. You just need to feel a slight flow on your cheek. So you can feel it like this, or you can taste it. Tastes like club soda. I find that sometimes when I start the flow, after a couple seconds it decreases again, so you want to always check that you've really got CO2 flowing. Okay, so this thin tube needs to fit down inside the Tygon 1. And you need to get the tube into the neck, not just to here. So you kind of have to move it around. And you want the tube to extend all the way into this bulbous part of the neck, sort of past the, see if I can do it in a way that can be seen a little better. There we go. So you can see it's extending all the way in here. Now at this point, you want to partially open this so that the space between the O-rings is exposed to the CO2, but this final O-ring still seals the vacuum in here. Okay, so it should look about like that. This final O-ring still looks nice and fat and sealed here, but you can see that the other one is not sealed. We want to have CO2 flushing through this for about 15 seconds before you actually put water in. But it can be longer than that, just at least 15 seconds. So while that's flushing, we'll start the flow of water. We're going to use a Niskin bottle here for our sampling, but whatever you want to use that you can start a flow of water from is fine. So this is what our sampling tube looks like. Again, we're using this thin nylon tube, and then there's just a couple of other pieces of tubing here that make it so it's the right size. Whatever thing you have that you can bridge from that to the nylon tube, it's good. So this fits on here pretty tightly. We've already opened our air vent for the Niskin. Start the flow of water. And you can see there's a big bubble in here, so we need to get rid of this. One way is to turn this up so that the bubble goes up. There's still a small bubble there, so hitting, tapping, whacking, squeezing, whatever method you want to use, get all those bubbles out. You should visually be able to see that they're gone. That looks pretty good. You can see the flow of water we have here. It's not super fast, but it'll do. We've been flushing this. So we leave the CO2 in there briefly, and I stuff this one with the water down with it. You can see the CO2 forcing bubbles and water and things up, so that tells you, yeah, the CO2 flow is still good. You can remove the CO2 tube. If you're trying to conserve CO2, just reach around and close off that little cutoff valve. And now this tube too has to get all the way down inside there. So right now it's stopped at the neck. I'll just move it around until I can get it right in there. Okay. There's still a big bubble of, it'll be CO2, but still something we don't really want in our sample up here. So we need to get rid of that, and the way to do that is to just tap the neck against your hand. You can see the bubbles moving out of there. I recommend that you do not wear rings for sampling because you'll run the risk of breaking the bottle. But you can see that you can give it a pretty good whack. You should visually see that all the bubbles are gone. That looks pretty good. So we'll put this back here. You want this pointed upward. And we're slowly going to open the neck. And I generally look right here at this point to see when water starts to actually enter the flask. So you can see it going in now. And then I look up here and I open it so that this water level stays around at this area. You can go a little lower, but obviously the important point is that it not go all the way to here, in which case you would suck air in. Now you notice that over time, the water flow into the flask sort of decreases a little bit, so you can end up opening it just a little bit more. Again, keeping that level about there. So it's starting to fill. We're going to wait until the bottle is about half full, and then we're going to close it. So this is the part at which patience is a virtue. You just have to wait. When you're doing your first couple samples, you'll probably want to just sit here and watch it because you'll be nervous. But when you've gotten good at it, this is a good time to then move on to prepping your next flask. And I'll demonstrate that in a moment. Okay, so we're reaching about the halfway point here. It's always good to remind yourself which way you're going to turn the stopcock, because we don't want to open it all the way and suddenly suck air in. The old rhyme, righty-tighty, lefty-loosey, applies here, so we're going to turn it to the right. And we can remove this.